All right, here we go. Last one, and this is a different one that we haven't done one like this before, so this will be good. And it's even an even one, so no answer in the back on this one. So check this out. Educated mothers, 1996 uses a baseline. 31% of students reported that their mothers had graduated from college. In 2000, 8368 said that it had grown to 32%. Is this evidence of a change in education? Now notice it doesn't say, is this evidence that the percent has increased? It says it's a change. Okay, so we're going to do a one proportion, because we're dealing with proportion of students who reported that their parents had graduated from college, z-test, where P is the proportion of students who said their parents graduated from college. So H0 would be P equals 0.31. HA, this is where I emphasize change, P is not equal to 0.31. Now this is the first time we've come across this, and we'll talk about it in class as well. So it's not equal to 0.31. So let's see what this means. Now, what's our evidence? Our evidence is P hat is 0.32, which is 2678 out of how many? 8368. I rounded this to nearest whole number, so it's approximately 32. But this would be my x over n. Okay, so here's my evidence. How do I know I can do this test? I got to check my conditions. Okay, first condition, of course, this gets pretty routine here, but you can't, because it's routine, you can't slack off on it. Respondents from 8368 figure shown this, doesn't really say anything, so we're going to assume a representative sample of all students. Number two, NP 8368, not NP, is less than 10% of the population. Of course, that's true. And number three, 8368 times 0.31 is equal to, and 8368 times 0.69. Do it on the calculator. 8368 times 0.31 is 2594.08. It's greater than 10, or equal to, and then times 69.69 is 5773.92, greater than equal to 10. So all of these, okay to proceed. They all allow us to say that this curve is approximately normal. So P hat distribution is approximately normal, and mu sub P hat is 0.31, and the standard deviation I know is 0.31 times 0.69 over 8368. Okay, now here's the interesting thing. This is a two-sided test. Okay, I'm actually going to go back here and say two-sided. Okay, or actually I should probably put it down here just for emphasis. I'll leave it in both for right now since it's the first time. Okay, our sample is 32. So here's 32. So since it's two-sided, P could be not, we just want to know if we have evidence for P not equal to 31. That means, what's the probability that it's greater than or equal to 31, like normal, but it could be that same distance the other way as well. So if this is 0.32, I'm going to change colors just for emphasis on this. If this is 32, the same distance this way would be 0.31. So what's the chance of me getting the same extreme value either side? That's what not equal to 31 means. Because I could go that extreme value above the average or below the average. Now, why am I worried about below the average when I just have this, when I only have one sample? It's precisely because I only have one sample. I'm only taking one sample for my evidence, but it could have been above or below, it doesn't matter. But we just want to know if I have evidence that it's not equal to 0.31. So it could be above or below. Well, how far above or below? The same distance, 1/100th above and 1/100th below. So I go up and down the same distance here and here, both ways. So this is my p-value. So I want to look at z. Same calculation here, 0.32 minus 0.31 over 0.31 times 0.69 over 8368. And so whatever this p-value is, I'm just going to double it. The nice thing is everything's the same on my calculator. I just have to remember to double the p-value. Okay, so I'm going to do a one prop z-test. Actually, sorry, I don't need that because my calculator does it for me. And when I do a one prop z-test, and I put in 0.31, x was, 2678, and was 8368. Portion not equal to p0, so it has a two-sided in here, so it's going to double the z-score for me. So I get z is 1.98. That's the z-score for the 0.32. Then the p-value is 0.32. Okay, so that's the p-values actually, because I said it was a two-sided test, it actually includes both of them, the areas on both, which is nice. So the probability, what this is saying is that's the probability of me getting a sample as extreme as the one I got on both directions, okay? That direction or that direction. Okay? So that's evidence, or not evidence. Well, let me restate that. Is that evidence that p is not equal to 0.31? Well, the chance of that happening, something more extreme, is 32%. Is that likely? Yeah, I mean, 32%. I'm not surprised if it happens, let's put it that way. So my conclusion, the p-value is 0.32 is much greater than 5%. Let's be consistent. 0.05 if I use that as my measuring stick. This is not evidence that that p is not equal to 31%. Ooh, but put that in context. What in the world's p again? Oh, that's good. I got it right here. That the proportion, this is another reason to write it out like that, the proportion of students who said that their parents graduated from college. Okay, this is not evidence that the proportion of students who said their parents graduated from college has changed. Right? That makes sense? Context. Percent has not changed. We don't have evidence that it has changed. Right? Okay, so that's a two-sided test. We will talk about it some more in class for sure. And we'll go from there. But process is exactly the same. Alrighty, there you go.